This question is one of the Department of Education past papers. So we are just going to do the algebra. On 1.1, we are required to solve for x. On 1.1.1, we are given the statement which is 2x minus 3 multiplied with x plus 7 equals to 0. So we are already given the factors of the quadratic equation here. What we are going to do, we are just going to say our 2x minus 3, it is equals to 0, or our x plus 7, it is equals to 0. Then moving on from there, our x on this side, it is going to be equals to 3 halves, or our x, it is going to be equals to negative 7, and then we are done. So now let's go straight to 1.1.2. On 1.1.2, we are given the quadratic equation, which is 7x squared plus 3x minus 2 equals to 0. And the statement told us that we have to leave our answer into 2 decimal places. So meaning that we are going to use the quadratic formula for finding the roots, which goes like this: x equals to minus b plus or minus the radical sign of b squared minus 4ac. And then we are going to divide everything with 2a. So for this formula, you can go back to your data sheet and then take the formula as it is. There is no mark for writing the formula, but there is a mark for substituting on the correct formula and substituting correctly. So we have this negative from the formula, and then we put our value for b, which is the coefficient of the middle term, which is 3, and then plus or minus. We said our b, it is 3, which means we are going to square it, and then minus 4 multiplied with our a, which is 7, multiplied with our c, which is negative 2 on this case, and then we divide with 2 multiplied by 7. And then when you get to this step, you just use the calculator and punch everything here as it is, but changing the signs from positive to negative and also from negative to positive. So if you use the positive here, you are just going to get the answer, which is 0.36, and then you will say, or x equals to, when you use the negative here, you will get negative 0.79 as your answer, and then we are done for this one. So now let's go straight to 1.1.3. On 1.1.3, looking at this statement, we have a radical sign x minus 1 added to 3 equals to x. So what we need to do here, we need to eliminate this 3 on the left and then also on the right. So we are just going to subtract 3 on both sides. If we subtract 3 on this side, we are going to remain with a radical of x minus 1. If we subtract 3 on this side, we are going to have x minus 3. And then after doing this step, we need to square this side in order to remove the radical sign. So if we square the left-hand side, we also need to square the right-hand side to balance the statement. And then this square, it is going to eliminate the radical sign, and then we are going to have x minus 1 equals to x squared minus 6x plus 9. And then after this step, we need to take everything to one side and then simplify that side. So after taking everything to one side and simplification, we are going to have x squared minus 7x plus 10 equals to 0. And then we are just going to try now and factorize our quadratic. And then in terms of the factors, we are going to have x minus 5 and x minus 2. And our x, it is going to be equals to 5, or our x, it is going to be equals to 2. Then now it is always wise, if we are working such a kind of a problem, to go back and substitute the value of x and see if it does give you the correct statement. So if we say our x on the right, it is 2, then which means on the left, we need to get a value which is 2 again. But under the radical sign, we will not going to get something that is negative, such that if we add 3, we are going to have a 2. So which means 2, it is not true for this statement, but we can substitute here 2, and then we are going to get 1. The radical sign of 1, it is 1. and then plus 3, it is 4, which is not equals to 2. And then let's substitute 5. If you substitute 5 here and subtract 1, you're going to get 4, and the square root of 4, it is 2, and then you add 3, and then you indeed get 5, which means the solution for this problem, x equals to 5, and x, it is not equals to 2. X is not equals to 2. So what you just need to do is to write this solution, which is x equals to 5. So now let's go to 1.1.4. On 1.1.4, we are given a quadratic, our quadratic, which is x squared. So I will try to do this so that I can explain this for you to understand, because understanding it is important. So I will try and draw these two equations, where this one, it is my x squared, and then also try to draw another one, which is going to be our straight line cutting this way. And then looking at this, we are going to have 3x plus 18 after simplification of this side here. So this line, it is going to cut at 18. If it cut at 18, and then if you can equate the two equations and solve for x, your x, it is going to be 6, or your x, it is going to be equals to -6, -3, where these two equations meet, meaning that the point here where they meet, it is -3 when it comes to x, and then the point here where they meet, your x, it is equals to 6. So this statement says that we are looking for a quadratic where it is greater than what? The straight line. So we know that this quadratic can be denoted as y equals to x squared. So which means we are looking for y of the quadratic where it is greater than the y values of the linear function. So looking at this, the quadratic, it is above the straight line. Looking at this portion as this function continues to positive infinity, our quadratic, it is above the straight line. So to represent that, we are going to say our x, it is where it is less than -3, meaning that it's from this point going to this direction as these two functions continues. And then say that our x, it is when it is greater than 6, meaning that it is from this point and goes to positive infinity as our functions continues, which means we are expected to get this answer when we are solving for x on this inequality. So let's just go straight for it. So upon solving that inequality, we are going to have x squared greater than 3 into x plus 6, and try to simplify the right. Our x squared is going to be greater than 3x plus 18, and then we are just going to take everything to one side. Our x squared minus 3x minus 18 is going to be greater than 0, and then find the factors for here. Our factors, it is going to be x minus 6 and x plus 3. So such that if we multiply -6 with +3, it is going to give us -18. So these two constants, they are the factors of 18. So if we say -6 plus 3, we're just going to get the coefficient of x, which is the middle term here. So if the middle term, it is negative, which means the value that is bigger, it is supposed to be negative. So our x here, we said it is going to be greater than 6. Or when it comes to here, we are not going to say our x, it is going to be greater than -3. But as we saw that our x, it is going to be less than -3. So something that I can tell you, maybe which is going to be a hint for you when you get here, is that if you are having a quadratic function and like this, and it is positive, as you see that the leading term here, it is positive. So which means if they said it is greater than 0, saying that the function, it is greater than 0, meaning that your signs, they are going to be like this, where on this one you say it is the smallest term, and then on this one it is the maximum value. It is going to be like this. But if your function here, it is positive, and the sign was like this, it is f at x. I will just write the equation as f at x less than 0. Then if your sign was like this, then your signs, they are going to be facing to this direction, and you put x, we put the bigger value, you put the smaller value, and then you are done. So now let's go straight to 1.2. On 1.2, we are given equations, which one of them it is 2y plus x equals 1. And then I will call this as my first equation, and then try to manipulate this equation and making x be the subject of the formula, which means I'm going to have 1 minus 2y, and I'll call that as my second equation. And then I'll look for the equation that I was given again, which is x squared plus y squared plus 3xy plus y equals to 0. And I will say this one, it is my third equation. So moving on from here, I will substitute my second equation into my third equation. Meaning that wherever I see x, I will try and substitute with 1 minus 2y. So I will begin by saying 1 minus 2y and square it since our x was squared, and add y squared, which was there, and then plus 3y, which is this one, 3 and y, and then multiply it with x, which is here 1 minus 2y, and then add y equated to 0. And then from here, I will try to simplify the left-hand side. So I will have 1 minus 4y plus 4y squared plus this y squared plus 3y plus 6y squared plus y equals to 0. And then moving on from here, I can see that I have this, and this as our values, or our terms that have y squared. So I'll try and add them, and then I'm going to have, okay, here the sign, it is negative. Here our sign, it is negative, which means I'm going to have negative y squared. And then moving on from here, I'll now pick this one, pick this one as the like terms, and then it is going to eliminate each other, but I'm going to remain with this constant, which is 1, and equate it to 0. And then moving on from here, I can see that I have a difference of 2 squares. So that can be factored by saying 1 minus y multiplied by 1 plus y equals to 0. And then which means the solution for y, it is going to be plus or minus 1. So now I need to find the values of x. So to find those values of x, we are going to go back to our equation, which we said it is going to be our second equation, where we wrote our x as the substitute of the formula, and say x equals to 1 minus 2. In the space of y, we are going to put negative 1, and then get the answer, which is going to be 3, which means that when our x equals to 3, our y equals to negative 1. And again, use this formula and this equation and say x equals to 1 minus 2. In the space of y, we put 1. And then our answer here, it is going to be equals to negative 1. Meaning that if our x equals to negative 1, then our y equals to 1. Then we are done with that one. So let's go straight to 1.3. On 1.3, we are given that if f at x equals to 0 has a root, which is x equals to. Looking at these roots, you can notice that they already substituted in the quadratic formula. So what we need to do here, we just need to look for the values of k that will make this statement or this equation to have equal roots. So once you hear about equal roots, that's the nature of roots. So meaning that our discriminant, it is supposed to be equal to 0. And we know that the discriminant, it is b squared minus 4ac. And we take it under the radical sign on the quadratic formula, on that quadratic formula for finding the roots. So since they already substituted, which means we already have that b squared minus 4ac as the substitution, which is now it is 3 minus 12k squared. And then we are going to equate it to 0 and then try to find the value of k from this statement. So what we are going to have here, we are going to have our k squared as equals to 3 divided by 12, which is equals to a quarter. And then moving on from here, because we are not looking for k squared, but we are looking for the value of k, so which means we are going to apply the radical sign and then also apply the radical sign on this side. And then the radical sign come with two solutions, which is positive and negative. Then our k, it is going to be plus or minus half, and then we are done. Thank you.